There are many interesting aspects to astronomy, one of which is magnitude. It's human nature to have a strong interest in big things, for example, the size of everything in the universe, the size of galaxies, the size of stars, and the size of planets has always been a source of interest for astronomy fans. One of these symbols of magnitude is the planet Jupiter. Jupiter is the fifth planet in the solar system. It is a gas giant, and Jupiter is not considered a metal planet. Of course, this planet is the largest planet in our solar system. Jupiter is a gas giant planet weighing 2.5 times the mass of all the planets in the solar system combined, and it has no solid surface. Regarding the size of Jupiter, its diameter at the equator is 142,984 kilometers, which is 1,321 times larger than our planet. But Jupiter is not 1,321 times heavier than our planet. It is only 318 times heavier than our planet. Because the density of our planet is more than 4 times that of Jupiter, the density of our planet is 5.5 grams per cubic centimeter, and the density of Jupiter is 1.326 grams per cubic centimeter. The density of Jupiter is almost the same as the density of the Sun. Because the composition of Jupiter consists mainly of hydrogen and helium, and the composition of the Sun is almost the same. But Jupiter does not emit light like the Sun. Because Jupiter is a planet and not a star. No matter how big Jupiter is, it is 10 times smaller than its star, the Sun. Jupiter's diameter is about 1/10 the diameter of the Sun, and Jupiter is considered to be 1,000 times lighter than the Sun. The reason for this is that the density of both is almost the same. Jupiter's average distance from the Sun is 778 million kilometers, making it the first of the outer planets in the solar system. The reason Jupiter has such a large size goes back to its history. Jupiter is the oldest planet in the solar system, having formed only 1 million years after the Sun and 50 million years before our planet. In this regard, the preceding phrase, eats more, fits Jupiter very well. Because the absence of other planets at the time of Jupiter's formation allowed Jupiter to accumulate more material easily. These materials included silicates, metal oxides, and gases. Today's solar system is very clear and clean, and when Jupiter was formed, there was a lot of free-flowing gas and planetary material, which is why the solar nebula had not yet completely dissipated. Because of this, Jupiter managed to absorb large quantities of hydrogen and helium from the solar nebula. The reason why the composition of the Sun and Jupiter is so close can be explained by this situation. First, the planet began to form as a solid core, and then it gathered a gaseous atmosphere around it. During its formation, Jupiter's mass increased slowly. At the beginning it was about 20 times the mass of Earth, and about half of its composition consisted of silicates, ices, and other heavy elements. After Proto-Jupiter's mass was 50 times that of our planet, a void began to form in the solar nebula. After that, the growing planet reached its final mass in 3 to 4 million years. Because Jupiter and the Sun are composed of the same elements, it is widely believed that the solar system had multiple proto-stellar systems early in its formation. But the solar system never became a multi-star system. This is why today Jupiter is not called a protostar or brown dwarf, because it does not have enough mass to fuse hydrogen. Jupiter is large enough to become a star, maybe even a little bigger. Because the smallest red dwarf is slightly smaller than Jupiter, it would need to be about 75 times Jupiter's current mass to fuse hydrogen. From this we can conclude that being big is not enough to become a star. The main condition for becoming a star is weight. Because of Jupiter's enormous size and weight, Jupiter is called the vacuum cleaner of the solar system. This is because the weight of Jupiter is 318 times heavier than the weight of our planet, so its gravity is also much heavier than the gravity of the Earth. In addition, due to the huge size of Jupiter, its impact-receiving surface is much larger, that is, the surface of Jupiter is 120 times larger than the surface of our planet. In other words, it is 61 billion square kilometers. An example of this is that Jupiter is called a dust collector because its gravity is seen to attract many celestial bodies in the solar system, such as asteroids and planets in the inner solar system. As an example, asteroids and comets with a mass destruction impact on our planet occur about once every 100 million years. If we take into account that the weight of Jupiter is 318 times heavier than the weight of our planet, if it were not for Jupiter, about 100 asteroids or comets would fall on our planet every 100 million years. And there would be 100 mass extinctions every 100 million years. A mass extinction event this frequent would reduce the likelihood of life on our planet to zero. For this reason, the presence of Jupiter can be seen as a guarantee of life on our planet, that is, Jupiter is a protective shield of our planet. To give an example, let's look at a famous event from the recent past, namely the July 1994 crash of the comet Shoemaker-Levy 9 into Jupiter, the most massive planet in the solar system. Was a clear evidence that objects are caught relatively often. Research has shown that the possibility of a meteorite or comet with a diameter of up to 300 meters to collide with Jupiter occurs once every 500 years. If we take into account that most of the celestial bodies moving in the universe are small bodies, and as these small bodies grow in size, their number also decreases. Taking this into account, the time interval between collisions with Jupiter for celestial bodies up to 1.6 kilometers in diameter is about 6,000 years. And the size of asteroids or comets with a large impact force of a level that would cause mass destruction on our planet. The interval between the collisions of celestial bodies with Jupiter can be said to be about 500,000 years. The fact that Jupiter appears so large to us is not its maximum size, meaning that Jupiter was larger in the past than it is now. Jupiter is shrinking in diameter by 1 millimeter every year due to its internal contraction process. According to the books, 4.5 billion years ago, Jupiter was twice its current size. Nevertheless, this planet is still the largest planet in the solar system, and yet we see Jupiter as a symbol of greatness, and its current size is enough to call Jupiter the king of the planets.